So guys, back with the Socket 478 MSI board, the 865 PE Neo 2/P board. Again, this is my original Pentium 4 board from back in the day. It's done quite a bit of mileage, so it doesn't surprise me that, you know, the AGP slot, as we seen in the previous video, was starting to give us grief. I've already gone through and done a full list of all the capacitors. Got, you know, the amount and the spec, and even, you know, I broke out the calipers, because especially around here you have to make sure you're getting the right size with these guys here. So yeah, I've ordered those up from RS Online. They should be here before the weekend, so we can recap the board. It does seem like a kind of a power thing, because when the AGP cards were in a lower power kind of draw state, they were fine. But when they started drawing more power, that's when we started to get an issue. You know, there's only so many charge and discharge cycles these guys can do, regardless of what the brand is. I've checked all the capacitors on the board. I'm not sure about the brand of the SMD, but I do know that these are all Rubicon. Rubicon are a good brand. It's surely only out of habit that I always get Panasonic and Nichicon. This would have gotten heavy use, because I was using it not just as a gaming PC and a regular daily driver, but for, you know, Unreal Engine 2, you know, all kinds of lighting, baking light maps, even baking old school light maps that you had to do in 3D Studio Max or something like that back in the day before you could do it in Engine. So yeah, I would have done all that kind of stuff on this board back in the day. So let's take a minute to just talk about the AGP slot itself and roughly how it works. I'm just an idiot with a soldering iron, so my explanation is going to be far from perfect and probably incorrect at times. So this is white paper on revision 2 AGP. But you kind of need to have all the documents together to get a full kind of all the info you need on AGP in general. Later revisions omitted kind of some of the basics of kind of pinout and things like that. They expected you to look at the kind of earlier documents. There's a lot in this. It's very engineering. It's very technical. So as a hobbyist, as an idiot with a soldering iron, I'm just going to kind of cover my understanding of the kind of basics of it. So we're going to skip to the electrical kind of specifications. I'll try and summarize what they're kind of covering here, but basically it's how the system derives the speed of the card, and it basically, from my understanding, it uses a reference voltage in the AGP controller, which is part of the North Bridge, that it looks at the supply voltage of the card, compares it to the reference voltage at the North Bridge, and that determines the speed at which the bus is going to run. So if I go down to 231, where we can actually see the pin allocation of the connector, what you'll notice is a lot of AGP cards, they'll have like they won't connect on certain pins. There will be no finger on that edge where it meets up with the pin, depending on what kind of supply voltage it takes. So if you kind of scroll through here, you'll see areas like this on pin 34, where we have VDDQ 3.3. That's under the 3.3 volt bus. Then you have the universal, which leaves it unlisted because I believe it does some kind of handshake with the card to ascertain the voltage, and 1.5 volt. Now later AGP slots use lower voltages, so just bear that in mind, that this is for revision 2, so later revisions are slightly different, but you'll see every so often, again here on pin 40, you'll see the different kind of supply voltages. I don't know if these are technically supply voltages, because if you look up here, you do actually have VCC, voltage collector to collector. So that's 3.3 volts. So I'd imagine that's fairly constant. So it's these pins here that are basically telling the North Bridge what speed the card runs at. Through some process I don't understand, it's basically using that reference voltage and a voltage in the North Bridge controller and figuring that out. So if these voltages aren't there, or they're a little off, and they're not there consistently, this device is running super fast, so if the voltages aren't correct at the right time, it's going to throw the timing and speed of the card off. So that could explain some of the problems we were having, that when it was in a high power draw state, when it was drawing a lot of power, then those bulk capacitors wouldn't have had the voltage required for the North Bridge to do its magic. So the timing of the kind of the timings were out, so that the display was becoming garbled, because it was displaying and it was working, but it was just garbled. I've just taken off the MSI heatsink on the North Bridge there, and the consistency of what's left here is like putty or sticky. You can kind of see it come off there. Try and get the shine off that, but it's, yeah, I've never actually changed that stuff, so that has to come off. So we're going to clean that off. So what I'm going to do right now is, while we're waiting on the capacitors to arrive, I'm just going to give the board a very good cleaning. So I have ordered the capacitors for the audio circuit. This is Realtek audio chip here. I have ordered the surface mount capacitors for that. So we will be doing that. There is a lot of surface mount around there, so I'm going to have to be careful and make sure I tape it up and get like tin foil on kind of the connectors and stuff. So hopefully the alcohol is kind of seeped in there. Can make some kind of headway of removing it. Okay, so we've got the goopiness is now gone from the top of the North Bridge controller. And I'm just kind of getting rid of any kind of dusty bits that may have landed on it. So I think that's as good as we're going to get it, folks. We're not really going to get it any cleaner than that. One thing we have to consider is this kind of stuff. As I was kind of cleaning it, it started to kind of degrade here. You can see it's kind of falling apart. You know what, it's there for a reason. I'm going to leave it there. So hopefully I have enough thermal paste. I have another syringe, but it would be nice to use up all this first. I think that's enough. If you look at that chip, so at first I thought something shorted out these pins. I think it's just gunk, oxidation. So it really does help to clean boards like this. So I'm not going to reflow it, but I am going to give it a good cleaning. So I'll get my toothbrush and some alcohol. So it's already looking a lot better. So what I'm going to do is we're going to go in with a fiberglass pen. I'm just going to rub. So it looks a bit better. I mean, I think to get it looking better again, we would have to reflow it, or at least, yeah, just get some flux on there to burn off whatever kind of oxidization has occurred, and kind of maybe fresh solder in there just to kind of fix it up. But I think for now that should be okay. It's not going to get any worse. Now I'm still waiting on my order from RS Online to arrive, but it's after lunch and I really want to make a start in this because I don't want to be doing this late into the night. So one of the good things about being a geek is whenever I order caps, I always double my order. I never order the amount I have, so quite possibly there's a lot of the caps that we need for this. So sorry about the sound of the desoldering station, but I've just removed the first cap from around the AGP slot. It's a 1000 microfarad 6.3 volt. Now this may be something or maybe nothing, but that leg on the negative terminal looks kind of dull-ish. So again, sorry about the noise of the desoldering station, but just as I began desoldering, the rest of the capacitors arrived. So I'm still going to use some of the ones that I identified from my stock, and the ones I ordered can just replace those. So I think I found our culprit. Either that looks like it could very well be electrolytic there. I get something a bit pointier to point with. It's not easy on a blackboard, but that looks like it could be electrolytic fluid. And there's also, it's harder to see there, and there's also a human hair, but eyelash. That looks like electrolytic as well. So those caps could very well have been leaking. So I'm going to clean those areas before I move on. So we took off 6.3 volt caps and we're putting on 10, but they are the same package size, so that should do nicely. Okay, now a fairly big tip on this, and that's more to do with trying to keep the heat, the kind of thermal mass of the iron up. So I've decided to come in here with flux. That'll hopefully kind of clean it off. Just make my life easier when it comes to these big ground planes on a multi-layer board. So I had the board in like a little vise. I've taken it out just to make this easier. So, well, that's the idea. Ooh, that looks good. Okay. Man, it's great having a new tip cleaner. When the old wire wool gets old, it's just pain in the ass. So I've just finished off the last of the electrolytics, and they're all done through hole. So it's getting pretty late, and I want to kind of maybe play some games. It's a Friday night, so I'm going to leave the surface mount guys in the hot air till tomorrow. But yeah, board has been recapped. We'll test it out. We'll do the audio circuit and test it out tomorrow. I've got 2 gigabytes of RAM here, my PS2 Gateway 2000 keyboard, and that's it. And we've got a monitor, just a bare bones setup. I could have tried it with a more low power graphics card, like dug out like a, I don't know, like an old ATI card or some. I have other kind of lower spec old school kind of cards, AGP cards, that probably would be better, but we'll see. So smoke test, hopefully no capacitors have been put in the wrong way around. Have I plugged in? Oh, like a doofus, we actually got to turn it on. So our fans have spun up. GeForce 256, there we go. Core cell. What was it to get into the BIOS? Delete. F1 to run setup. So, frequency voltage. So it appears to have posted at least. I'm not going to, I'll edit, not save my settings, but I'm just going to shut it down now, and we'll just turn it off. So what I want to do now is get a hard drive hooked up, and we'll see what happens. I have a SATA, one of those BX500s, the cheap ones. Plugged in. What I'll do is we'll power on, we'll go back into the setup, we'll set the boot priority, and we'll see if it'll boot. GeForce 6600 LE AGP. Now before, you would have noticed that this machine wasn't even booting with anything in the AGP slot, so I think we may have repaired that. So run setup. Did I run setup? Reset. I'm just tapping F2 here and delete. Okay, so that's to change color, F2. Good to know. We'll leave it in blue with yellow. Standard CMOS. Primary ID not detected. So what we want is advanced chipset features. AGP. No. Advanced BIOS features. Boot device select. First. Okay, so what we need to do is we need to set up the IDE controller. Advanced chipset features, DRAM timings, no. Integrated peripherals, here we are. So USB, onboard, IDE configuration. So you can see here it says PATA only, parallel ATA. So we want PATA and SATA. Yeah, I'm going to have to save and exit now so that I can detect the drive. Reset didn't stick. Okay, something went wrong there. Because this is also intermittent, I'm starting to think it's a power thing, you know. And I'm just kind of poking around, feeling stuff for heat. North Bridge is quite hot. And that's what I suspect, of one of my suspicions, either voltage or... Because you've seen the AGP work. Faults are quite intermittent, and if the RAM wasn't working it just wouldn't start. And that is quite warm to the touch. I don't know if... I can't remember if this board is temperature sensors or what the story is. But yeah, we'll let it do its thing and we'll come back. So I'm going to go ahead with a press F8, is it, to agree? I'm going to go ahead with a Windows XP Professional. To continue using this setup partition, okay, we're on a partition that contains another operation. Partition. Start a motherboard. Okay, no. So what do I want to do with this? Delete partition. And to delete, press Enter. To delete this partition, press L. Install. Quick format. Okay, so we're going to format that. This was the drive that was in the ASRock. So yeah, we're going to install XP 32-bit Pro on this, just for shigigs. But what I think is going on, so Occam's razor would mean that we start with the AGP slot and check the solder joints on the back of the AGP slot. We've been pulling cards in and out of this, you know, not just here in the channel, but like throughout the years. So I'll reflow that. Hopefully that makes a difference. At least now I'll have an operating system, so when I do repairs on the board I can try and boot all the way with something in the AGP slot. I'm not going to... Matrox, chances are Windows XP has a driver for that, so it's going to install it automatically, but I'm not worried about that. So once we have a full bootable kind of setup, fair enough, I'll reflow the AGP slot, see if that works. What do I think after that? Well, I think we're into dangerous territory then. We either have a problem with the voltage regulation. These, I can't remember, there's a name for them. I'll put it up in text on the screen. But basically they're like a buck converter. You see them on graphics cards, you see them by CPUs and ATX setups. Could be that. It seems to be a power thing because we've seen it boot off AGP. That wouldn't be the case if it was the North Bridge, but man, the heatsink on that is hot. I mean, that's super hot. I know it's meant to get hot, but I'm just worried it's too hot. Maybe a thermal pad on that would have been a better idea than thermal grease, and I don't have any thermal pads. Just so I can monitor the temperature here at the North Bridge. I suspect it's going to be quite high. Celsius, because we're not savages. So we've got a light on there. You've got around 20 degrees ambient here. I think you can see it there. I'll put it on top of the DVD drive so you can see it better. 45, 44, 44, so probably add 20 onto that. We're at 64 degrees. The actual heatsink itself on the CPU is quite cool. So we'll continue on with the installation. I'll keep an eye on the temperature. So it's zipping through the installation. It says 34 minutes there. It'll take far less than that. Temperatures hovering around 45 degrees on the heatsink of the North Bridge. Yeah, this is just basically about getting a stable-ish kind of a setup. So I can boot to an OS, and once I can boot to an OS, I have a full kind of setup to test the AGP then. Okay, so I reflowed the AGP slot, all 66 pins, using a bit of flux and a tiny bit of solder. So my soldering station is kind of in the way of the screen. I'll try and set that up. Yeah. So I have power on. The setup is the same. I kind of left the battery in the board by accident. I should have taken that out when I was soldering, but I didn't. So let's fire it up. Okay, so it's booting now with something in the AGP. PMY G4 6600 LE AGP. Core cell extreme chip. BIOS screen. It's posted. Yeah, I was expecting to see the bar. And yeah, we still have this corruption. We still have corruption on the AGP. So it wasn't the AGP connector. So I'm gonna power it off. Okay, so 6200 in. It's not giving out about the AGP anymore, so maybe one of the pins did have like a cold solder joint there. So we're expecting the bar at the bottom. There we go, new hardware configuration. And a Windows XP boot. There we go. We still haven't figured out why the 6600 card doesn't work with this machine but is fine with others. So I'm just going to shut down. Nothing. It's intermittent. This is reset. And nothing. Won't even start now. Something's going wrong with power when it starts drawing more power. That seems to be the problem. Okay, so I've got the computer set up on the bench again, on the desktop here. And what we're going to look at is MOSFETs around the AGP slot. Now there's 3 of them here, and I'll zoom in so you can get a better look at them shortly. But as you've seen, I did desolder and check out these, and they seem fine. If there was a problem with these, we would see that the CPU just wouldn't do anything. It wouldn't start up. If I'll go to the other screen in a minute just to show you a section of the user manual that covers this chip here, the MSI core cell. The core cell is kind of like a temperature and power management chip. It monitors the power and the temperatures going to all over the board. So it's more than likely driving the reset line when our AGP card is in, and it just keeps resetting. The machine keeps looping through a reset cycle. So it's probably the core cell that's doing that. You'll notice I have the CMOS battery pulled right now. I'll install that before we power it up. So this is the chip responsible for monitoring temperatures and power around the board. So if I go to the desktop here, you can see the actual page. This is very basic information on the actual core cell chip itself and what it does. I couldn't really find anything more detailed than that. So, because it's the AGP slot that's given us problems, and that it boots fine with a PCI card in there, I know it's not the VRMs up here. It's not the... there's two MOSFETs, a coil, and a capacitor making up these three kind of phase VRM or three stage VRM. So I know it's not them, because it operates perfectly fine with PCI. For a burn-in time, about an hour or 2 hours, it's fine. Whereas I can get it to desktop with a lower power AGP card, such as the 62,000, but when I put, or 62,000, or the 6,200 card in there, when I put this card, the 6,600, this is going to be drawing a lot more power, and that's when we start pushing into these recycled or reset cycles. So let me zoom in and we'll have a look at the MOSFETs that I'm talking about. So if you look here on the board at the rear of the AGP slot, you'll notice that there's MOSFET here, one sitting awkwardly in underneath the kind of retention part of the AGP, and another over here. And there's also one down here, but my suspicions is because this is further down and closer to the PCI slots that this has more to do with regulation of the power on the PCI slots. I'd imagine it's these three here that are primarily for our AGP slot. So recapping the board brought back AGP functionality. But what I suspect is that one of these MOSFETs is bad and is potentially, operating out of range. Its temperature's too high. It can't supply enough voltage. It's not switching fast enough. So, if we look up the part number of the MOSFETs, I'll go to the desktop. So here's the datasheet for our MOSFET here. It's a PHD 45N03LTA. And N-channel logic level field effect power transistor in a plastic package using trench MOS technology. This is a discontinued obsolete part, so if you were an engineer, you could possibly find and knew what you were looking for. You could find a modern equivalent, but me being a noob and just a hobbyist, I'll probably source, or I have sourced new old stock for these, rather than take the risk of maybe getting something that, in the reference data and limiting values was slightly off. I think with something like a fast part, like a MOSFET, you probably want to get bang on spec what's needed. And I don't know where, I've looked for parts with the same specs, and it's not something that your average hobbyist is going to have an easy time doing. So you can see a lot of technical data on the kind of specs of the MOSFET. But basically these are the FETs. So if I go back to our scene, so if we were to consider testing these, what I'd like to do first is get an idea for which ones are good and which ones are bad. So if we call this one A, this one B, and this one C. So I'm just going to even write that down here. So A, B, and C. And I may even do a little graphic to have on the screen so you guys can see kind of as I test them what's going on. So the idea is I want to test temperatures. So let me just zoom out again. So I have my multimeter here and I have my thermocouple, basic thermocouple hooked up. Now obviously the outer temperature on the casing, that's the internal junction temperature inside is going to be a lot hotter. But this gives us a good idea of, obviously the one that's kind of the hottest is the one we're going to turn our attention to and possibly has a fault. Again, I don't have any hard or fast rules for as regards what the temperature of any of these should be, but I can reference them to each other, and because there's perhaps 5 or 6 of these type MOSFETs around the board. So if I can kind of get an average from them all and kind of work it that way. So these are the AGP ones. We said A, B, and C. This being C. We'll call this one D, the one further down. And it's a little out of shot. I'll see if I can get it into shot. And okay, you can probably see it down now, just between those two capacitors. We have E, we'll call this one. So we'll get an average temperature from them all, and we'll check them all, and we'll work our way through them. What I want to do is place the thermocouple just like here. So just on top of the ceramic portion of the package, or the plastic portion of the package. If I can get the little actual loop itself to touch the kind of backing plate where it's attached to ground, and kind of in against that and the actual package plastic part, that should give me a kind of a decent temperature to go around and check. Now on some it's going to be very tricky. I'm gonna, like here, I don't have access to that, so maybe the best idea is just to put the thermocouple up against the actual plastic part of the package. Okay, just for the purpose of testing, and because this offers even greater access around here, it's not as bulky as a card, I've taken out the 6600 and put in the 6200. And again, we're testing this guy here. Just going to give it a couple of minutes. Okay, so you can see our ambient there is at around 27 degrees. So I'm going to try and touch MOSFET A. Okay, so we're on the top of MOSFET A there, and you can see the temperature rising. So we're climbing up and slowing down now. So around 28, 28.5, slowly creeping up. 28.9, 29. You can see the temperature gains are incremental and quite slow. And we'll really slow it down. Kind of crawling up now. I'd imagine this will get to about 40 degrees. If I were to stay on here. But the operating temperature, that seems quite normal. I mean, it is getting hotter, but it's expected to get more. So, let me try and get a temperature off the B, which is the one just here. And this is going to be a lot harder, hence the reason why I put in the 6200. I'll try and do it in a way so that you guys can still see. Okay, so we're on B. You can see the temperature is actually going up a lot quicker here, and now it's starting to slow down a bit, and we're climbing. towards, yeah, again, like I think this would probably go up to 40 degrees if I left it here long enough, but I'm happy enough with that. It looks like it's operating in kind of in or around what we'd expect. It's not out of control as such. So let's check side C. Let's put the thermocouple on there. Okay, so we're going up a lot faster. It's not slowing down. It's ramping up. We're over 37. We're up on nearly 40. Okay, so I just kind of got better contact on it there, and yeah, you can see we're up on 60. Are we going to approach 60? So when you see it drop like that, that's the reset kicking in, I'd imagine. Yeah, so we're at 53. 54, reset, and we're going up again. So just gonna rest on it again. 53. Okay, so that one's noticeably hotter. And we're going to check site D now. So we're about 10 degrees down on that one. It's 46. But yeah, if I go back to C, you can see that, yeah, that's considerably hotter. So the internal junction temperature is, you know, probably 3 times this value. I don't know. I'm not an engineer. I'm just kind of guessing that, you know. So that's 54. We go back to D. Yeah, we're literally 10 degrees cooler. Although that one seems to be climbing now. You could operate in a pair. Okay, so what I want to do is there's one here at the back, closer to the USB ports. So this is E, MOSFET E, and that one's actually 31 and falling. Obviously this one's probably not under load, so it's still worth measuring because it gives us an idea of what a one that's not under load is going to do. So yeah, that's the temperatures with that one. So our outlier is kind of MOSFET C, this guy here, right here. So what I'll do is I'm going to hold in the button to power it off. Hopefully it powers it off. There we go. I'm just going to flick off the adapter. I'm taking out the 6200. And you guessed it, I'm putting back in the 66. And I'm going to see what happens. To see what temperature that is. So we're climbing rapidly. We're over 50 degrees. just have to kind of... It's pretty awkward trying to get this. Let's see, we're 55. And climbing. Still climbing. So I've no doubt that this machine's currently resetting. Even though, you know, the fan hasn't stopped, it's just going to, you know, the fan's going to continuously run until I turn it off. But you can, unless there was a problem with the CPU. But yeah, we're at 56.8. I'm just moving my hand to make sure I'm still on the money point. 52, 53. Yeah, so this one is definitely hotter than the others. So I'm going to check the temperature on the next one down again. 748, 48.9, 49. That seems pretty stable. Still hotter. Go back to C. Oop. Okay. $56. Yeah, this one is 70. Yeah, I have no doubt that this would go up to 60. You can see those temperature drops, I'd imagine, are actually during the reset. So yeah, this one's going to have no trouble going up to 60, I'd imagine. We've seen that, you know, A and B were kind of in around 40 degrees. They seemed happy enough. But the real one that kind of went a bit, how would you say, it was a lot, you know, the outlier as such was this guy right here. Temperature probably would have exceeded 60 degrees. You can kind of see the point I was testing, which is right here. I was pushing the thermocouple right up here. Yeah, I have no doubt that, you know, the temperature probably would have got to 70 eventually if I had left the thermocouple there long enough. You could see the power, the temperature reading drop a little and rise again. Those rise and falls were due to the reset. It was just resetting. So for a couple of seconds or even milliseconds, you know, the power was dropping off, so the temperature would drop and then it would rise again with the power, you know, the reset coming on again. So, what does all this kind of mean? Well, it means that I more than likely have to replace this MOSFET here. Again, these are obsolete, discontinued parts. If you were an engineer, you could possibly source the equivalent in a new series one with all the same electrical characteristics and package size, etc., etc. I don't know enough about MOSFETs to do that. So I went in, I had a go, but it was just too hard. And usually from RS Online or Farnell, the package type was completely different. Yeah, and I wasn't confident enough to go ahead and order those, because the last thing you want to do is put the wrong type of device there. So again, you know, these are a Philips device, discontinued. I was able to find them on eBay. I got 9 of them from China. The price before post and packaging, I think, was maybe €6 or €7. You know, that's roughly, you know, around $5 or $6, or 450 sterling or something like that. But, you know, getting them here in time is going to be a problem. it'll be another week or two, at least before they get here. I did pay extra for the express shipping, so I don't know how long it's going to take for them to arrive. So that's a bit of a pain. It does mean that we're kind of waiting on parts. I figure, we're all waiting on parts at the moment, considering the global human malware situation. So for now, there's not much I can do. I'll replace this guy here, as we are calling it, MOSFET C. This one was slightly warmer. We'll see about replacing that. Also, this guy here, the one that's right in underneath the retention arm for the AGP card, that's going to be really hard to get to if I need to replace it. So, in a worst case scenario, I have to desolder the AGP port and use hot air to get these off. So, in a way, if it's a case that I am replacing one, then I replace them all. Because if I'm going to the hassle of desoldering the AGP port, then I'm definitely going to replace them all. Because, chances are, if one is out of spec and is getting overly hot like that, then it's only a matter of time before the others do too. There's a reason why there's heat sinks on them, because they do need heat sinks. So what we'll also do is we'll kind of look into maybe, is there a way to kind of keep them cool? Could I mount a fan somewhere to kind of blow air down onto them? That's something that I'm going to consider. But yeah, if we do end up having to desolder the AGP slot, we're going to have to be obviously very careful in doing that because it has to go back on. Finding a new one of these is going to be a pain in the ass. So that's the plan. We are going to replace these PhD 45NO3 LTA MOSFETs. I'm nearly sure that this is the culprit. So if I can get away with replacing just this one, that will be great. And it also means that I can just tinfoil up around here and put a bit of Captain tape here and there and just use the hot air to quickly work this guy off. So I've never replaced one of these style packages before. I'm hoping it doesn't require a lot of heat for a lot of time. I don't want to be overly harsh to the board, but it appears that that's what we've got to do. We've got to replace that MOSFET. So in the next video, in a couple of weeks' time, those MOSFETs should have arrived, and we'll get to replacing this and testing out the system once they've been replaced. So cool, guys. The board will live again. Thanks for tuning in. I'll chat to you all again.